Okay, so the first thing that we're going to look at with our factoring would be our first step, which is GCF. So you're looking for a greatest common factor. Now with this, the best thing to do is start with the smallest number that you're seeing and go from there. So I'm going to start with 24. But will 24 divide into 54? No. So then let's talk about some factors of 24. So what do y'all think? 6, right? 6, yeah, 6 and 4. So we're going to choose the larger of the two, so 6. And then let's go through and look at our letters. Does anybody remember how we choose what value of our variable to pick? Okay, and the one that they have in common, which in this case is going to be the cube. You choose the smaller exponent. So notice we're looking at two different exponents. Choose the smaller, which is going to be y cubed. And then we go back inside the parentheses and we divide and get what's left over. So here 24 divided by 6, that's 4, isn't it? And then here with our exponents, we are dividing with like basis, so we subtract our exponents. So 4 minus 3 is 1, isn't it? Do we have to write that 1? No. And then we're going to have our minus. And let's see, 54 divided by 6, most days that is 9 most days. And then subtract your exponent, so 3 minus 3 is 0, so all my y's are gone for that term. And for this one, inside the parentheses, you do look to see if it'll factor again, but here it will not. So you are finished. A lot of people forget that taking out a GCF isn't really the first step in factoring. It is still factoring. You feel like it's not, but it is. So let's look at number 2. Number 2, again, start with your numbers. Start with 17. Always pick the smaller. Now, will 17 divide into 51? It will. That's a weird one. It goes 3 times, doesn't it? Okay, now look, both terms have an a, so choose the smaller. So it's going to be a cubed and b to the 4th. Then we start our parentheses with what's left over. And 3 goes into, or 17. Why? I am thinking of the answer there, right? Sorry, guys. That should be 17. This is 3 on the inside. Sorry. Okay, so 17 goes into 51 3 times. A to what power? A to the 8 minus 3, so that's 5. And b to the 0, which means it's gone, right? And then plus... what would be my next term? See, 17 divided by 17 is 1. A, 3 minus 3, so that's gone. So it looks like I'm just left with B, isn't it? So that would be our final answer. I'm going to rewrite that down here. That looks terrible. It's 17A cubed B to the 4th was your GCF, and the remaining part, 3A to the 5th plus B. All right, questions about it? Any questions? So that's the first step with every one of these in your homework. Do check for a GCF. Now for the next part of this, we're going to go into factoring the difference of two squares. So the first thing we need to do to help us remember this is to list out those squares, those perfect squares. So let's go ahead and list those out. We know 1 is a perfect square. 4 would be a perfect square. 9, right? Let's see, 16, 25. Y'all remember all of those? 36, 49, and so forth. So there's all your perfect squares. And then the rule for factoring, and we have to be careful here. Notice it says the difference of two squares. So we're going to look and see, well, what's being squared minus what else is being squared. And when we figure out what is being squared, then we can go ahead and factor it. That will factor into x minus y times x plus y. Now, something I want y'all to make a note of, just a side note here, you need to remember that something squared plus something squared, and this always shows up on that ACT, and it gets everybody. You cannot factor the sum of squares using real numbers. This is going to be prime. And they're going to trick you, and I'm going to have one on a quiz, and it'll be something squared plus something squared. I'm already telling you I'm going to try to trick you with that, so be careful. That is always prime. Okay, so down at the bottom on number 3, some people don't want to rewrite it as something squared minus something squared. I'll leave that up to you. If you're rusty with your factoring, it's a good idea to do it the first couple of problems until you get used to it. All right, so for number 3, I always rewrite these two things. I need to know, well, what's being squared on the first term minus what's being squared on the second term. That way I have it in the difference of two squares format. What is being squared to give me 36w squared? 6w, isn't it? Minus what squared gave me 25? 5. Now, really, for our formula we just wrote, we have x and y. We're just filling in the blanks now. So our factored form would be 6w minus 5 times 6w plus 5. So it is useful to try to figure out what's being squared first before you start the factoring. However, if you're good with factoring and you can do that in your head, there's nothing wrong with being smart. By all means, continue to do so. Okay, look at number 4. Now, a lot of times when we get to fractions, we're always freaky with fractions here. What is going on with that first term? What is being squared to give me 144? 12, but now it's a fraction, it's 1 over 144, right? So it's really thinking about what's being squared in the top, which is 1, what's being squared in the bottom, which is 12. You can look at them individually that way. Okay, now for our exponents on the other, we know it's r and s, right? Now when we raised an exponent to an exponent, we multiplied. So here with r to the 6th, this has to be r to what power so that when I multiply it to 2, I get back 6. 3. And so what would that mean s's exponent is? 2. A quick way to do that is just divide. You can divide your exponents. Divide 6 by 2 and 4 by 2. Does that always work? Absolutely. Okay, now we're ready to fill in our parentheses. We have 1 over 12 minus r cubed s squared times 1 over 12 plus r cubed s squared. So doing that first step, in my opinion, is very useful. But again, if you can do that in your head, nothing wrong with that. Questions about 3 and 4? Seem okay? What's the answer to 5? Oh, I told you I was going to trick you. Look what you just wrote. That's something squared plus something squared, isn't it? That's a tricky one. We can't factor the sum of squares. So this one, number 5, is prime. Why is it prime? What is making the difference? That plus sign. That's why this is called the difference of two squares. You're finding the difference. You're subtracting. It's not called the sum of two squares, is it? So you have to be careful with that. That one is prime, and it's going to trick you, and it tricked several already today. Okay, y'all try number 6 on your own, and then I will write in the answer. All right, so let's see. What is being squared in our first part? We've got 3, a squared, and b. All of that's being squared. Is that okay? minus what is being squared at the other part? 10c, isn't it? So now we're ready for our factored part. So we have 3a squared b minus 10c times 3a squared b plus 10c. Any questions about it? Any questions? Okay, now we're going to talk about the sum of cubes. So let's list out some cubes. And I was told y'all did not look at this last year, so this should be new. This is the new portion of the factoring. And it does show up on the ACT, not a tremendous amount, but just enough to be annoying for sure. So let's go ahead and list out our perfect cubes would be just like doing our perfect squares. So when we list these out, we're really just going through our numbers and cubing them. So my perfect cube, of course, we would start with 1. And then 2 to the third power. That would be 8, wouldn't it? Not 6, it's 8. Let's see, 3 to the third, that's 27. 4 to the third, what's that going to be? 64, is it? Is that okay? Let's see, 5 to the third, 125. And then 216. And then we pick up a calculator. All right, so that's your cubes. And on the test, I would never give anything larger than that. That's about it because, I mean, going past that is just kind of silly. All right, so the rules for factoring your cubes. So again, just like the squareds, we're going to say something cubed plus something else cubed. And again, notice with this one, we can use plus here. With the cubes, you're going to have a sum and a difference formula. But with your squares, there's only a difference. Okay, so to factor this, it's just a formula. The first parentheses is going to be your x plus y. It's what's being cubed plus what's being cubed. If you start with the plus, your first parentheses will always have a plus in it. Now for the next part, you're going to square that x. So you're going to get x squared. You have a sign change here. Then you multiply x and y. And then the last term's always plus every time. And then it's y squared. And this is just a big formula. Once you figure out what x and y will be, you're plugging into this formula every time. Okay, so let's try number 7. With number 7, again, on the cubes, I would suggest you rewriting this. But again, if you can do it in your head, that's great. We're going to have h is being cubed here, plus what is being cubed over here? That's just 5, isn't it? 5 to the third power. So now I know what my x and y values are, and you just plug in. So my first parentheses should be just h plus 5. Then I start my second parentheses. And then you square h, so that's just going to be h squared. You have a sign change. You multiply, so h times 5, that's just 5h, isn't it? Last term is always positive, and you square 5, so that gives you 25. Now, when you do your cube formula, this portion right here, that is going to be prime. You're not going to be able to factor that portion anymore. Now, for this part here, this could factor again, so you have to be careful with that. It could factor. So that portion, you're going to get 2 separate parts. And again, one of those 2 might factor again. All right, let's try number 8. It's the same pattern again. You're looking to see what's being cubed. So here, what's being cubed in that first term? 2f, isn't it? Plus, what's being cubed over here? 3, isn't it? 3 cubed. So now we're ready for our first parentheses, which is going to be 2f plus 3. It's exactly what we have there. And then for our first term, we need to square that too, and the f. A lot of times people forget to square the f. Both parts of that term get squared. So that's going to be 4f squared. So be careful with that. Now we have a sign change. We multiply 2f and 3, so that's going to give me 6f, isn't it? And then plus, what's 3 squared? 3 times 3, 9. Okay, questions about it? And again, the second parentheses, that's going to be prime. Now, first parentheses, 2f plus 3, we can't factor that. All right, y'all try 9 and 10, and then I will go through them. Let's go ahead and check these. So for the first part, it looks like a 3 and an a are being cubed. What's being cubed to give me 512? 8. Okay. So let's see. Go ahead and plug into our formula. So our first parentheses, we have 3a plus 8. And in our second parentheses, you should have 9a squared minus 24a, right? And then plus 64. Did y'all get that? Awesome. Any questions about it? Right? So let's do the next one. My goodness, these people are crazy. What cube gives me 729? 9. Oh my goodness. And m to what power? The second. And that's being cubed. Again, remember, for these exponents, since this is cubed, you can divide that exponent by 3 to get what goes inside the parentheses there. Plus, let's see, that's going to be 4n, isn't it? Okay, so our first parentheses, we're going to have, let's see, gosh, 9m squared, but I've got to square that, right? So that's going to be 81, m to what power? Oh, wait, I skipped that very first one, didn't I? Sorry, I'm on crack. So 9m squared, no, my crack's wearing off. Plus 4n, I'm going to have to get some Fireball. All right, times. Now let's square the first one. 9m squared, we said that was 81, m to the... It's to the second, but it's raised to the second, and an exponent raised to an exponent, you multiply. So that's really m to the fourth. M to the fourth. Did anybody get m to the fourth? Oh, awesome. Good job. Okay, and then minus, 9 times 4, 36 m squared n, and then plus, what's that last term going to be? Perfect. Y'all are factoring monsters. Any questions about it? Any questions? Y'all look. Make sure I didn't mess up. All right. So let's look at the next ones. And notice that says the difference. And we're going to work through all of those by any means. I am going to give you the formula. And the reason why I'm saying I'm not working through these is because it's the same exact thing. It just has a different sign to it. So looking at the formula, the rule for factoring, you're still talking about the cubes, but this time it's the difference. So we're going to look at x all cubed minus y all cubed. And it's really the same exact formula. All you're doing is making sign changes, and there's only really one major sign change. Up at the beginning, with all of these that we just worked through, you had x plus y in the parentheses. But guess what this one's going to be? X minus y. It's going to mimic whatever sign you're given. And then inside our formula, the other part, you're going to have x squared. And this time that one's going to change to a plus. And you still have xy, and the last term is still plus y squared. So again, the only difference in the sum and difference formula for cubes would be these signs right here, the first and second signs. And you can always remember those because that first sign is always what you're given. The second is the opposite of it. That's the only difference in those. That's why there's really not a major need to go through 4 more cube problems. I think y'all got them. Any questions about those? Right? So look over at factoring trinomials. Do y'all remember how to factor trinomials? See a lot of yeses going on there. All right, so I'm going to skip that. I'm not going to bore you senseless with that. What about factor by grouping? Do y'all remember how to factor by grouping? No, that one we need to review. All right, so let's do factor by grouping. I'll do example 21, and most everybody, once I get about halfway through this, they're like, oh yeah, I remember this. All right, so when you factor by grouping, always try to group the first 2 terms plus sign last 2 terms. Doesn't always work, but about 90% of the time it does. So let's try it. We're going to group the first 2. So I'm going to put in parentheses 2h cubed minus 3h squared. So I'm grouping those first 2. Always a plus sign. And then group the last 2. 6h minus 9. Now, after you group the first 2, plus sign last 2, then you go through and you look at what's common. You take out a GCF from both parentheses. So here on that first parentheses, it looks like I've got an h squared that's common. So I'm going to factor that out. And so I'm going to be left with a 2h minus 3. Is that groovy? Plus, what about 6h minus 9? What's common? 3. Is this starting to look familiar? 2h minus 3's left, right? How do you know you're on the right track with factor by grouping? The parentheses are the same. This stuff right here is the same. That's how you know you're on the right track. So then I'm going to pull that down to h minus 3. And then the other parentheses is going to be this other stuff right here. So it's going to be h squared plus 3. Does that look familiar with y'all? Yeah. Do I need to do another example with factor by grouping? No? Y'all are okay with it? Awesome.